Hello friends, welcome back to Civil Depth BD. Today I will show you how to calculate wind load parameters to input them into ETABS. And here I will use BNBC 2020, which is similar to ASC code. At first go to define, then go to load pattern. Here I will write WX, that means wind in X direction. Under type I will select wind. Auto lateral load I will take AC 705. Now click on add new load. For wind Y, just change the name and again click on add new load. So if I select wind X and click modify lateral load, here you can see ETABS needs several parameters here, like windward coefficient, leeward coefficient, wind speed, exposure type, etc. So we have to calculate them manually. Here I will use BNBC 2020 as I said earlier, which is similar to ASC code. Now I have prepared a list for the page number. At first I will go to page number 559. Okay. So go to page number 559. Under 559, you can see a equation which ETABS will use for calculating the velocity, pressure of wind. Now we have to go to page number 574. Here you can see a chart for wall pressure coefficient Cp, which is depending on the L by B ratio of the structure. Now for windward wall, you can see whatever the value of L and B, the value of Cp is constant, that means 0.8. But for the leeward wall, if L by B ratio is between 0 to 1, in that case Cp equals minus 0.5. If the ratio is 2, in that case Cp value will be minus 0.3, and for greater than 4, Cp value will be minus 0.2. But if the value is between 1.1 to 1.9, in that case we have to make interpolation to get the value of Cp. If the value is between 2.1 to 3.9, in that case again we have to make interpolation of this value so that we can get the actual value of Cp. So from here you can understand that for leeward wall the value of Cp is not constant, but for windward wall whatever the value of L and B doesn't matter at all. The value is constant, which is 0.8. Okay, fine. Then go to page number 603. Here in 603 you can see basic wind speed V for selected location. Here we are designing this structure for Chittagong. That means wind speed is 80 meter per second. 80 meter per second. Okay, fine. Again go to surface roughness category. We need to determine the surface roughness category. Then we have to determine the occupancy category, right? So at first go to 554. Here surface roughness category is directly connected with the exposure type of the structure. Okay, in short I can say if the structure is in a urban area where there have several obstacles for wind load, in that case you can consider your structure under exposure A. If your structure is in an area where do not have sufficient obstacle, in that case you can consider exposure B. If you are doing this design for coastal area where there is no sufficient obstacle and also higher chance of wind attack, in that case you can consider your structure under exposure C. That means exposure A for sufficient obstacle available, exposure B for insufficient obstacle but not in a coastal area, and exposure C for coastal area where do not have sufficient obstacle, right? Okay. Now we will go for occupancy category 483. From here, for earthquake and calculation, we already know that the occupancy category of our structure is 2. Then go to importance factor 604. Importance factor for wind loads. Here the occupancy category of our structure is 2, and this structure is located on non-cyclone prone regions. That means we have to take importance, we have to take the value of importance factor, which is 1. Next, go to topographical factor, that means 556. For topographical factor, the recommended value as per code is 1. Okay, KZT equals 1. Now, to find the Gust factor, go to page number 556. That means in similar page. Here for rigid structure, you can take Gust factor value as 0.85. Okay, but for semi-rigid structure, you have to calculate the value from the equations given by the code. No worry, here I will use Excel. By using that Excel file, you can calculate Gust factor for both rigid and semi-rigid structure. Now, how to take decision that either our structure is rigid or not? So, for that I have to go to page number 517. Here you can see building or other structure rigid. A building or other structure whose fundamental frequency is greater than or equal to 1 Hz. That means if the fundamental frequency of a structure is greater than 1 Hz, in that case we will say the structure is rigid. So go to ETABS, go to define, go to load pattern, modify. Here time period is 0.618. So if we need to calculate the frequency, that means 1 divided by T, 1 divided by 0.618, which is greater than 1. That means we can say the type of our structure is rigid. But we have to consider some other parameters. If you feel that there have some chances of differential displacement in your structure, in that case you can consider your structure as semi-rigid or flexible. I will suggest you to follow this webinar by CSI America, rigid versus semi-rigid. CSI America. Okay, you can follow this webinar for better understanding of rigid versus semi-rigid structure. Now I will find out the value of directionality factor at page number 606. So go to page number 606. In our case, we will consider that the structure is rigid. Wind directionality factor, here for buildings main wind force resisting system, the value will be 0.85, right? Now for eccentricity ratio, we can take the value from 577. Here I will consider the maximum eccentricity ratio, which is 0.15. That means EY divided by BY. So that's all. Now I will, what is eccentricity actually? Okay, what is eccentricity? Eccentricity is the difference between center of mass and center of rigidity. Suppose this point is for center of mass and this point is for center of rigidity. So there have some difference in value for x direction and also for the y direction. Okay, so this difference is considered as the eccentricity, and higher accepted value is 0.15. This is a regular structure, so I will not go for checking the eccentricity. In some other tutorial, I will discuss this issue more elaborately, but for this structure, I feel there is no necessity to calculate the eccentricity manually. Okay, here I will take 0.15, which is the highest acceptable value. So now go to the Excel file. Here go to main wind force resisting system. Then click on enable editing. Under wind direction normal, then go to wind speed V, which was 80 meter per second, but we need this wind speed in mph unit, that means mile per hour. So what we have to do, 80 into 2.24, that means 179 point something. Here I will use 180. Building classification, which is 2, exposure type. If your structure is under exposure category A, in ETABS you have to consider exposure category B. If your structure is under exposure category C, you have to consider, B. In that case, you have to consider here C. If your structure is under exposure category C, you have to consider D in this Excel sheet and also in ETABS, right? So our structure is under exposure category A. So here I am considering exposure category B. Hope you can understand this. Ridge height versus eave height. For our structure, there is no difference between ridge height and eave height. Ridge height means if you have a gable type slope or monoslope, in that case, the point at which two slope is being intersected is considered as the ridge height. But for our structure, we will consider the same height as we do not have any gable or monoslope type roof. So for our case, to find out the ridge height, I will go to ETABS, or you can say the eave height, similar thing. Edit stories and grid system, modify slash show story data, which is 72 feet. Okay, highest dimension 72 feet. Also the eave height will be 72 feet. Building width and building length, very important thing. Suppose here wind is passing through the x direction. In that case, the dimension which is parallel to x should be considered as L and the perpendicular dimension should be considered as B. If wind is passing through y direction, in that case, the dimension of the structure which is parallel to the y direction should be considered as L and the opposite or perpendicular dimension should be considered as B. So, for our structure, we have to open the CAD file. Here, suppose wind is passing through x direction. So, what will be the value of L? The value of L should be this one. That means which is parallel to x direction, 46 feet 10 inches, right? And what will be the value of L? What will be the value of B? The value of B should be 48.6. That means L equals 46 feet 10 inches and B equals 40 48 feet 8 inches. So go to Excel file again. Here you can see building width. Doesn't matter at all what you are writing here. The important thing is you have to check these two value with this L and B value. So here in building width B, here I will use 46 feet 10 inches. And this value should be 48 feet 8 inches. So for when I am calculating wind load parameters for x direction, here you can see L equals 46 feet 10 inches. That means which is parallel to x direction. 46 feet 10 inches. Wind is passing through this direction. Wind is passing through x direction, and here the parallel dimension, and here the parallel dimension I am considering as L, and the opposite or perpendicular one as B. So be careful when you are doing this. Roof type here not important at all. 46 feet 10 inches, or we can write 46.82 and 48.67. Okay. Now roof type is not important. Topographical factor KZT, keep it as 1. Directionality factor 0.85, fine. Enclosed, yes. Hurricane region, no. Damping ratio 0.050, both as per ACI and AC code and BNBC. CET. So for taking decision about CET, we have to go to the previous episode where we made earthquake calculation. From here I can see that the value of CET is 0.0466. 0.0466. Okay. Now you can see this Excel file has calculated the Gust factor value and the coefficient for windward wall and leeward wall, but this is not accurate for BNBC 2020. Just a little difference, because if I go downward, here you can see this Excel sheet is calculating time period T by considering the height of the structure in FPS unit. Okay, but as per BNBC 2020, we have to calculate the time period by using SI unit. That means in this Excel sheet they are considering the value of H in feet unit, right? But we have to consider, here you can see in the previous episode we taken the value of HN in meter, but this Excel sheet is calculating the value in feet. So if you are following BNBC 2020, in that case just we need to make a little modification here. Just unprotect the sheet. Okay, just write down the value of time period here, which was 0.618. 0.618. Okay, that's the thing. Now here we will get the actual Gust factor value, actual windward coefficient and leeward coefficient. Okay, so let's go to ETABS. Go to define, then load patterns, wind X, go to modify, user define, Windward coefficient value should be always 0.8, but leeward coefficient value which is 0.50. Okay. Then here I will select create all set eccentricity ratio. I will take 0.15 as I discussed earlier. Wind speed 179.2, or we can take 180 also, similar 180. Exposure type, you can see here is no option for exposure type A. You have to take exposure B. Importance factor 1, topographical factor 1, Gust factor is also 0.85, directionality factor 0.85. Bottom story height, we have to select story 1 to water tank top slab, include parapet, take the height 3.5. Here in wind direction, I am using 0 degree for wind X, but for wind Y we have to use 90 degree. Now for calculating the wind Y, what we have to do, just select parallel. Just select parallel. Okay. Now you can see Gust factor 0.85. Go to modify lateral load. User define here 0.49. Create all set 180. Exposure B, importance factor 1, as it is actually. This is a very small building. Include parapet which is 3.5. And also the main thing which is modify slash show, here I have to input 90 degree. So by this way we can calculate the wind load parameters to input them into ETABS. That's all for today. See you in the next tutorial. Thank you.